Hey everybody, welcome to our Gradeful's daily SAT, ACT test prep chat. We stream every day from Monday to Friday at noon Eastern time. And the topics vary from SAT questions to ACT questions to general test prep talk. Your hosts are myself, Patrick Spano, and our resident math wizard, Mr. Alex Torres. And today's topic is ACT formulas you must know before you take the math section. So these are just things, they're things you have to know. And if you don't, your math score is not going to be what you want. So we'll let Alex take it from there.
Alrighty, so there are a ton of things. The ACT math section is incredibly broad, and you're not given a lot of the formulas. A lot of times you're given a formula when it's one that they feel like is hard enough that okay, you're given a formula when it's so hard that they feel like, okay, this is acceptable for you to not know this. But there are so many that are right underneath that line where, you know, it's considered easy enough that you should know this thing. So let's go ahead and go into the first one. Nice and easy on the ACT is going to be the idea that sine squared x plus cosine squared x equals 1. So you can expect a nice easy question that says like sine squared x equals 3/4 and find cosine squared x. So nice easy concept there.
So this will be for any trick questions. And I believe this is a formula that is sometimes given, but you still suggest students should know it by heart, correct?
Yeah, I would say it's not given more often than it is given. And this is one that we covered in a recent podcast on the same topic. Another similar one is the law of sines and the law of cosines. So as fast as you're going to see me rattle these out on my page, you should be able to. Once again, occasionally we see these given and sometimes we don't. So if you're really shooting for that high score, you can't hope that they're just going to give it to you. So law of sines and cosines right there, two formulas you need to memorize. And just the idea, sorry about that, just the idea that both of them are about what's across from what. So for instance, if I have angle A and side A, angle B and side B, then it's about the relationship between the angle and the side that's across from each other. So if, you know, if I have these three blue things and I'm missing this green thing, that's perfect, because I can say sine A over A equals sine B over B and then solve for the one unknown. And similar on the law of cosines, same idea. I might have this. The big thing about cosines is that the one that's the C has to be the one that sort of we're thinking about in terms of this angle. So if this is our angle, either the unknown angle we're solving for or the single angle we're given, then that needs to be the central. That needs to be the C right here and the C right here.
Very good point. And I would just also like to add, I think that memorizing these cosine, sine, those questions tend to come up pretty frequently. I know that there's a lot of different concepts the ACT likes to test. Some are a little less common, but I would say that these are very good rules to put on the board first because they are for sure must-knows. Very good. What else you got for us?
Okay, so if you don't have it memorized already, you absolutely should memorize the quadratic formula. I know maybe about 60% of American students probably don't have this memorized right now in high school. But x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And the way I kind of announce that, almost like a little bit of a song, certain things are easy to remember visually. Like to me, sine A over A, sine B over B, that's kind of something that I see in my mind. But certain things are better in an auditory sense. Like a lot of schools around the world that teach this, they teach a song that you just kind of hear in your ear and then you hear it in the sort of the inner monologue in your head. So you got to have that memorized, right? And
so would you explain, you know, what's the main use for this, maybe for any students that are maybe have it memorized, they're not sure when to use it, or don't have it memorized and aren't sure when to use it?
So, okay, so you have BC factoring. If I had numbers in this spot and this spot, but not in the purple spot, then the way to solve would be asking myself, well, what two numbers add to 7 and multiply to 9? That's BC factoring. If I have a number in the purple spot as well, then I'm asking, okay, what two numbers add to B7 and multiply to AC? And that leads me down the ABC factoring method. If you're hearing this, you want more explanation on that, let us know in the comments. We'll be more than happy to do a lesson just on that method. But if something doesn't factor, then that's when the quadratic formula, if a quadratic doesn't factor, the quadratic formula is one of the next things that you try and next thing in your bag of tricks. So you find out what A, B, and C are, and you go ahead and just plug them in. So here with these numbers, it'd be -7 plus or minus square root of 7 squared minus 4 times 2 times 9 all over 2 times 2. The hardest thing in the calculation part of this is that you need a single sign right here. And I was just doing this earlier just with my own daughter, explaining that you need these three things to just be right there. So you can get a single sign for that and calculate. Notice that here, the thing that we're subtracting would actually be bigger than the 49. So you have a negative under a radical. And that takes us into our next subject, which is to say, simply based on the b squared minus 4ac part of the quadratic, which we refer to as the discriminant, you're going to know how many solutions. So in the example that I just invented off the top of my head, there would actually be no solutions to this because you can't have a negative under a radical, right? So just inventing fake numbers here based on different values under the radical, I'll just say the quadratic formula would end up looking like 2 plus or minus square root of 4 over 3, 2 plus or minus square root of 0 over 3, 2 plus or minus square root of negative 4 over 3. So all I'm doing is I'm varying this number. Everything else is staying the same. And here you would have 2 plus 2 over 3, 2 minus 2 over 3, 2 answers. Here you'd have 2 plus or minus nothing over 3. It's just 2 over 3. It's one answer. And here you'd have a negative under a radical. That's not allowed in the world of math. So we have no answers, no solutions, as is more popularly called there.
Very good explanations. And then also, I think a big point, you have to memorize and know the formulas. However, it's very important, as we're doing here, practice with real test questions going through the formula. It is not enough to just have it memorized, then you get to test day, and then when it's time to actually plug numbers in, you panic or you're not really sure what to do. Make sure that you practice with the real test questions, applying your knowledge of the formula and how exactly to use it. Can't emphasize that enough. Keep going.
All right, awesome. So a next thing we can talk about are logarithms. So logs are just pretty much all memorization. So I'm going to go through a bunch of steps that you need to be able to rattle off the top of your head really easy. So for instance, if I had a to the b power equals x, I need to be able to convert that to log base a of x equals b. The tip there is that the bases stay the same. So the base in the exponential language is a, and the base in logs is still a. But the other two guys switch places. So notice that the b and the x just traded places as we go from exponential form into log form. So where would this be useful? Let's say that I had 5 to the x equals 15, right? Well, a calculator is not going to have anything you can do with an x power, but I can convert to logarithmic form. Log base 5 of 15 equals x. So the base stayed the same. The other two guys switched. And that actually brings us to the next rule I wanted to talk about. So this was rule number 1 right here in yellow. Rule number 2 is going to be the idea that I could have log base 5 of 15 becomes log 15 over log 5. That's called the change of base formula right there. So that's the next big thing that you would need to know when it comes to logarithms, is to be able to take something like that and turn to something like this. And then, like I said, that's all logs are, is a series of things that you want to kind of have memorized. And the next big one when it comes to logs is the idea that the log of a plus the log of b equals the log of a times b, and the converse, or the opposite, log of a minus log of b equals the log of a over b. So you can just imagine all sorts of little questions where something like this would come up. For instance, a question might say the log of a minus the log of 5 equals the log of 15. So now applying the rule, the bottom rule from the two that are in yellow there, this one should become the log of a over 5 equals log of 15. And therefore, a over 5 equals 15. And we can solve right there. So when it comes to logs, there's only one more rule that I would really emphasize, which is the idea that if I have a log of a and it's to the b power, we have to know that that could be turned into the log of a, but the b comes out front. That's called the power rule in logs. So, you know, just countless bricks that make up the house of what you would need to know in order to do well on the ACT. So here you could imagine a question that says, you know, the log of 5 to the x power equals 10. And what do we do with that? Well, if we bring the x out front according to the power rule, x log 5 equals 10, we could divide both sides by log 5, and x is whatever you get for 10 divided by log 5. So just countless things where if you know the rule, you get the point. If you don't know the rule, you don't get the point. And one of the sayings that we say frequently is, does it make you smarter or less smart to be on either side of that coin? No, it doesn't. But of course, you want to know the rule so you can impress the colleges as much as possible. Get into your dream college and never think about this stuff again.
So that's exactly right, and that's what we like. Yeah, that's what we like to preach here. Is that these tests, the ACT, the SAT, are very, very content based. So it doesn't necessarily make you smarter, but you'll be much better prepared for it. And again, if you don't know these formulas, you can't just pull them out of thin air. You need to prepare, and these are things you should be working on. Students will often ask, what should I be studying? What should I be memorizing? Specifically for the ACT math, all the formulas that we've gone over here up till now. So I'll let you continue.
Alrighty. So the next big one that I would want to emphasize would be sequences. So we're talking about arithmetic and geometric sequences. And I don't know, it just bothers me when I hear people call these arithmetic sequences. It's arithmetic, dude. We've known that word since we were in grade school, right? Arithmetic. Is that a hard word, guys? Are you seeing the arithmetic and geo on my screen right now, by the way? Patrick?
Yes.
Just to make sure I unpaused. Yep. Okay, so the idea of a sequence is you have a starting number and you're doing something to that number, and you're doing it n-1 times. So now arithmetic sequences are where you're adding, geometric sequences are where you're multiplying. So an arithmetic sequence would be something like 5, 8, 11, 14, 17, and so on. A geometric sequence would be something like 5, 10, 20, 40, 80, and so on. So here we're adding 3, and here we are multiplying by 2. So the formulas you need to know. For the arithmetic, the number you're looking for is equal to the first number plus the thing you're adding, and you're adding it n-1 times. For the geometric, you have the starting number, but you're multiplying by something n-1 times. So what does D stand for? It's the common difference. It gets at the idea that the thing you're adding, you could figure it out by subtracting. If I wanted to know what we were adding here, you know, if it were a harder thing to figure out, I would say 17 minus 14. So when you're adding, you subtract to figure out. That's why the thing that you're adding is called the common difference. Similarly, when you're multiplying, the thing that you're multiplying is called the common ratio. Because if I wanted to know what we were multiplying by, I would take the 80 and 40 and divide them. And division is kind of like a ratio. So the common ratio is the thing that you're multiplying by. And you need to know both of these formulas in order to handle lots of questions. So for instance, I might get this sequence here that we have in pink. And the question might say, well, what is the 98th term of that? So what's the 98th term? A98 is equal to A1, the first term, 5, plus the thing that we're adding, 3, n-1 times. So 98 minus 1. N is the number of the term you're talking about. So 97 times. So 98 minus 1. And so that's whatever you get for 5 plus 3 times 97. And that comes out to 296. So the 98th term of the sequence that I just highlighted in pink there is actually 296. And one last thing to add to our conversation about sequences for the arithmetic sequence, is that the sum of n numbers is n over 2 a1 plus an. So for instance, if I wanted the sum of the first 98 terms, that would be 98 over 2, 3 plus 296. And whatever that simplifies to, that would be the sum of the first 98 terms.
Very, very good explanation. And again, if you're only tuning in right now, this is why you need to subscribe to our channel. Test prep experts. We both have been tutoring clients for many, many years. We've been tutoring students for specifically these tests. And I think that is this type of breakdown is, I think, what stops most students from being able to grasp maybe the harder looking concepts or concepts they're not seeing at school at the moment. So again, stay tuned, look at our other videos, a lot more videos to come. But for this breakdown of exactly what you need to know, what you need to memorize, how it looks, what the terms are, and how the ACT might test it or the SAT might test it. So very good explanation. I think we'll have time maybe for one more, or depending on how long the rule is, and then we can wrap up for today.
All right, sounds good to me. So let's go ahead and jump into the next one now. This would be the idea that if I had something like 5 over 2 plus 3i, or similarly 5 over 3 minus 2 radical 5. Both of these are in a format that we don't want. We don't want I or a radical on the bottom. And so a lot of times you'll see, what's an equivalent expression to these, which is just asking you to practice that skill. And what we're talking about is the complex conjugate. When you have a binomial denominator that you don't want, you actually take advantage of the idea of differences of squares, which we'll get into deeper at some other point. But that's the reason why this works. To say that when we multiply by the same thing with the opposite sign, it's going to cancel everything that we don't want in the denominator. Because when you have a plus b times a minus b, the outer and inner terms of FOIL cancel out, if that makes sense verbally. So distributing on the top, 10 minus 15i. On the bottom, first times first, outer times outer, inner times inner, last times last, and I squared is -1. These two cancel each other. So you have -9 times -1 is +9. So 4 plus 9 on the bottom. 10 minus 15i over 13. And we've successfully gotten I out of the denominator. Similarly here, we can distribute the top. 6 times 3 is 18. 6 times 2 radical 5 is 12 root 5. And then on the bottom, first times first, outer times outer, inner times inner, last times last. So 2 root 5 times 2 root 5 is 4 times 5. Root 5 times root 5 is 5. These cancel just like we had on the I example. 4 times 5 is 20, so 9 minus 20, -11. 18 plus 2 root 5 over -11, and that would be how you would use the conjugate to solve when you have an unwinded binomial denominator.
Very good explanation. If it was a little quick for some of you, if you're trying to keep up, it's your first time seeing it, the videos will all be posted after. So if you're not watching it live, or even if you are, just make sure that you pause it later, take time, look at some practice questions. So again, thanks for that, Alex. That'll be it for today. You can meet us back here tomorrow at noon. And you can check out our new website at gradefultestprep.com. Subscribe to our YouTube channel. All of our videos are linked on our site as well. And we'll be posting little sound bites and little test prep tricks to our Instagram and our Twitter and our Facebook pages also. But again, comment, you can subscribe. And on our website also, if there's any specific test questions you need help with, you can upload a picture of it, and then we will take the time during the week to answer them for you. So make sure that you spread the word. And as always, thanks for tuning in, and we'll see you guys tomorrow at noontime for a little test prep chat.
All right, guys, take care. We'll talk to you soon.